So this lesson is on the primary trigonometric ratios. This is lesson 2. First of all, what we are going to be dealing with in this lesson is primarily right angle triangles. Okay? So for any right angle triangle, and that's important, the primary trigonometric ratios are defined in terms of an acute interior angle. We call that theta. Okay? So what that means is we need a right triangle. These don't work if you don't have a right angle in your triangle. And we're going to be working with some angle that is acute, means less than 90 degrees, inside the triangle, and we've called it theta. So if you take a look at this diagram here, this is in your notes, we would refer to, in this example, this is the angle we're working with. This is theta. We usually call the angles the capital letters on each corner. So this is A, capital B, and capital C. And we usually mark the sides across from those angles with the smaller case letter. Okay, little a goes across from big A, little b goes across from big B, and little c goes across from big C. So basically what the word ratio means is fraction. Okay, so when I say calculate a trigonometric ratio, I mean calculate one of these. So the sine of some angle, all this word means is that we're looking at the ratio, the fraction, between side length A over side length C. This is always, sine always refers to the length of the opposite and over the length of the hypotenuse. So the hypotenuse, we know, that's the one that is the longest side length, and it is directly across from the 90-degree angle. But how do we know which one is the opposite and which one is adjacent? Remember, we're always referring to one angle. So we have to have the angle that we're talking about. In this case, we're looking at A. We have to have that labeled because that'll change which one is which. The side opposite is always the one where if I took my angle, it's the one that I could point to across the angle. It's the one that doesn't touch the angle. Okay. So the opposite in this case is little a. So it'll always be that way. If we're working with angle A, little a will be the opposite, if we've labeled our triangle correctly. And that means the adjacent is the one that directly touches it, but is not the hypotenuse. Okay? The hypotenuse has to touch the angle you're working with, because we're always working with an acute angle, which means less than 90 degrees. So we're working with either this angle, or we're working with this angle. Cosine is the length of the adjacent side, B, divided by the length of hypotenuse. And tangent is the length of the side opposite A, adjacent. Sorry, not adjacent, sorry, opposite A, divided by the adjacent B. So the fun little acronym for remembering that, I'm sure many of you will have heard this before, is SOHCAHTOA. Okay. You could also write that out as S is O over H, C is A over H, and T is O over A. SOHCAHTOA. It's just a handy little acronym for remembering it. So recall, let's revisit all this. The hypotenuse is the longest, it's the longest side, and it is always located across from the 90-degree angle. Okay? So it's always located across from the 90-degree angle. Ooh. Okay. when labeling the sides of any triangle, the sides assigned the smaller letter. Smaller case letter of the angle directly across from it. Okay, so that's what we went through. Little a goes across from big angle big A. The primary trigonometric ratios can be used to determine side lengths or angle measurements in a right angle triangle. Just to reiterate that point. It has to be a right angle triangle or it doesn't work.